Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, how are you? I hope you okay. Let me introduce myself. My name is Selma Zahra. My student ID number is 210291881. My study program is Mathematics Education Class A. Okay, I will try to explain the topic about extreme value of function and creating graphics of function. 9.1 Up function and down function. Definition 9.1. 1. The function is said to increase on the interval a if for any x1, x2 element I with x1 is smaller than x2, then f(x1) is smaller than f(x2). 2. The function is said to descend on the interval a if for any with x1, x2 element I, then f(x1) is more than f(x2). Theorem 9.1. Consider a function that has a derivative on a closed interval a, b. 1. If f(x) is more than 0 for every x in a, b, then f increases in a, b. 2. If f(x) is smaller than 0 for every x in a, b, then I goes down to a, b. 9.2 Extreme value. Definition 9.2. The function f is said to have a relative maximum value at c if there is an open interval containing c, so that fc is more than or equal to fx for x into interval. 2. The function f is said to have a relative minimum value at c if there is an open interval containing c, so that fc is less than or equal to fx for x into interval. The function f, which has a relative maximum or relative minimum at c, is said to have a relative extreme at c. Definition 9.3. If f accent c is equal to 0, then the function f is said to be stationary at c. The value of fc is called the stationary value of the point c. fc is called the stationary point of I. Theorem 9.2. If f is definite at a, b, and has a relative extreme at c, a less than c less than b, then f0 is equal to 0 or f accent c does not exist. Theorem 9.3. First derivative test for relative extreme. Suppose f has a derivative around c except perhaps in c itself. 1. If f accent x is more than 0 for x is smaller than c and fx is smaller than 0 for c is smaller than x, then the function f has relative maximum value in c. 2. If for x is smaller than c and for c is smaller than x, then the function f has a relative minimum. In conclusion, the step for determining the relative extreme of a the function is: 1. Determine fx. 2. Determine the critical number of x values. Fx is equal to or fx does not exist. 3. Use the first derivative test. Theorem 9.3. Concave and inflection points. Definition 9.4. The graph of the function f is said to be concave up on the interval if the graph of f lies above all of its tangent to I. The graph of the function f is said to be concave down on the interval I. If the graph of f lies below all of its tangent to I. Theorem 9.4 Concavity test. 1. If f double accent x is more than 0 for all x in I, then the graph is concave up in I. 2. If f double accent x is smaller than 0 for all x in 1, then the graph is downward concave in I. Definition of 9.5. Point P on a curve is called an inflection point if the curve changes from concave up to concave down, or from concave down to concave up at P. Theorem 9.5. If I has a derivative on the interval containing C, and C, FC is a pointer, then F double accent C exists, and F double accent C is equal to 0. Theorem 9.6. Second derivative test for relative extreme. Suppose we have a derivative and on an open interval containing f accent C is equal to 0. If f accent C is smaller than 0, then f has a relative maximum value at C. 2. If C is more than I, has a relative minimum value at C. 9.3. Absolute extreme at closed interval. Definition 9.6. Suppose that the function f is definite on a closed interval and C is a member of the interval. 1. If fc is more than or equal to fx for all x in the interval, then fc is called the absolute maximum value of f in the interval, that interval. 2. If fc is less than or equal to fx for all x in the interval, then c is called the value of absolute minimum of f in the interval. 3. If c absolute maximum or absolute minimum, then c is called the absolute extreme value of f. Theorem 9.7. Extreme value theorem. If I is continuous in closed interval a, b, then f reaches absolute maximum and absolute minimum value in a, b. Close interval method to find the absolute maximum and minimum values of a continuous function I on a closed interval a, b. 1. Find the value of f at the critical number I in a, b. 2. Find the value of f at the boundary points of the interval. 3. Compare the value in step 1 and 2, the largest of which is absolute maximum value. The smallest is the absolute minimum value. 9.4. Drawing graphs of algebraic function. We have guidelines for sketching the graph of the function y is equal to fx. 1. Origin. The y-intercept of the axis is 0, and we take the x-intercept for y. 0. 3. Asymptote. A flat asymptote. B. The asymptote is upright. 4. Interval up and down. 5. Extreme values and their types. 6. Concave and inflection point. 7. Sketch the curve. 9.5. optimization issues. In the following, we summarize the steps in solving optimization problems. 1. Understanding the problem. Read carefully until you understand. Ask yourself, what is not noun? What are the noun quantities? What are the conditions given? 2. Draw diagram. If possible, draw a diagram. 3. Introduce notation. Give a symbol for a quantity that must be maximized or minimized. Example F. Also choose the unknown quantities. Example A, B, C until X, Y. 4. Create the equation F in the symbols of the unknown quantities. 5. Use the maximum and minimum determine methods in this chapter. Okay, thank you for watching. Thank you for listening and watching. Assalamualaikum warahmatullahi wabarakatuh.